Hello. In this video I'm going to show how to run one-way ANCOVA. ANCOVA is analysis of covariance and how to test the assumption and interpret the outcome. Here we have three variables such as right, read, and levels of socioeconomic status, and the researcher asked 200 students a question. ANCOVA techniques usually used when we want to see the impact of interaction controlling by another scale variable. So ANCOVA significantly reduces the error variance compared with ANOVA. In ANCOVA include one variable is categories, nominal, which is level, low level, middle level, and high level of socioeconomic, and two dependent variables, scale or continuous, read and write. ANCOVA always allow you to remove the effect of covariance. So here we have some assumption before we start analyzing covariance. The first assumption, all the assumption related to ANOVA, like random sample. Second, dependent variable and covariate variable measure a scale or continuous. Third, independent variable contain two or more categorical group. Four, dependent variable approximately normally distributed. And five, convert, like right in our example, must be correlated with dependent variable read, meaning that a linear relation between the covariate right and the dependent variable read. 6. Homogeneity of regression slope, which we have to test the assumption of homogeneity of regression slope, meaning that the slope of regression represents the relationship between covariate and dependent variable are similar. And 7, we have to test the homogeneity of variance through the Levene's test of equality of the variance. This is by adding our control variable right. In our example, to be different from ANOVA, must we choose custom from the model, and we look to the p-value of the interact of levels star right must be greater than 5% in order to meet the assumption of homogeneity. ANCOVA is the extension of ANOVA. ANCOVA is just ANOVA with C added to it. C stands for covariance, ANOVA analysis of mean or variance, and ANCOVA analysis of covariance. So in covariance is the measure of the joint reliability between two variables. And here we have to check this assumption of ANCOVA. How? First, as setting up the data as you can see in SPSS. And then we have to first, before we start with ANCOVA, I have to test normality. How? I go to graph, I go to analyze, descriptive statistic, explore, put read and write under the dependent variable list, because we are going to test the normality of the dependent variable. Then plot, take the histogram and normality, plot with test, press continue and press OK. Now we have the outcome, descriptive and test of normality. Let me first start with the descriptive. And here in the descriptive you can see we look to the skewness and cortices, as you can see it here, the stat and the standard error. Then we divide the statistic for skewness and cortices by the standard error. If the result lies between plus 1.96 and minus 1.96, meaning that the data are or the variable are normally distributed, otherwise data are not normally distributed. So look at the table for normality test. You can see two measurement, Kolmogorov and Shapiro. In this table, mathematical table, we are interested in looking at the sig or p-value. If p-value of the dependent variable read and write greater than 5%, it means that the data or the variable are normally distributed. Otherwise, if p-value less than 5%, the data are not normally distributed, and this is, in our case, our data is not normally distributed in this example. Second, we have to check, even if we look to the histogram, you can see the histogram are not normally distributed. The second assumption, we have to test the linearity. How? I'll go to graph, legacy dialogues, scatter plot, select simple, scattered, defined, as you can put it here, reset, put dependent variable in y-axis, independent variable, which is the dependent variable, which is covariate into axis, and label the categories with set markers by level of socioeconomic. And then we press OK. Here we are looking for the scatter diagram. In the scatter diagram, as you can see it here, double click, go to elements, select fit line as subgroup, and then close it. You can see that in file, close, you can see that a scatter diagram with 3 fitted line. This is the fitted line equation, y 20.7, y 19.8, y 20.2, plus the independent variable x. A scatter diagram here indicates that the relation between dependent variable and covariate. Dependent indicate the relationship between dependent variable read and covariate write was linear. As you can see, all the 3 lines for the socioeconomic are parallel to each other, which is fitted line, straight line. In addition, the scattered plot suggests that the regression slope were similar or similar, and F test indicating that there was no an interaction between right and level. So if we are not sure about the 3 line, these 3 line, to violate the assumption, we have to test whether statistically significant between the interaction, level and right, and other independent variable, which is right, the covariate. We have a 3 line represent 3 level. 3 line represent 3 level, and as you can high, level, low. So this line represent the level of socioeconomic, which represent the line of best fit for each level of the socioeconomic level. Then we have to check if p-value less than 5%, this means that violated the assumption, so it is perform the statistical check of the assumption. Then I'll go to test the homogeneity of regression, and this is, we are still in using ANOVA, not in ANCOVA. How? We have to go to analyze, general linear model, univariate, 2 independent variable, or 1 level, which is categories with 3 level. This is the independent variable, and read is the dependent variable, right is the covariate, which is another dependent variable. And then we have to check the interaction. I go to model, I select custom model or custom term, then I move this variable to the right hand side, click, and then line, level, by star, and right, then add. This is the interaction between the two levels, the covariate and the independent variable. Then we press OK, continue, and then press OK. We'll go to the testing in the table here. Test of between subject effect. Mainly the interaction between level and right. This part here. And then we look to the sig value or p value or the probability value. So our guide is if the p value less than 5%, meaning that the statistically significant, meaning that this violated the assumption. If p value less than 5% violated the assumption of homogeneity. Yes. But we want to be p value to be greater than 5%. So from the outcome we have p value 0.879, which is greater than 0.05. This means that we have not violated the assumption of homogeneity of regression. This means that the three levels of socioeconomic are different from each other. And this is what we have here in this table. Level, star, right, covariance, and this is p-value, and this represents greater than 5%. So our guideline is when p-value less than 5%, meaning that the interaction is statistically significant, which means that violated the assumption of the homogeneity of regression slopes. So we do not want p-value less than 5% or statistically significant, but we wanted p-value greater than 5%, so we can look at the graph are similar, which is statistically significant if we look. Okay. But here we have p-value greater than 5%, so this means that statistically not significant, which is that's what we are looking for. This means this test not violated the assumption of the regression slopes. So we have to assume that we met the assumption of homogeneity of regression slopes. The second part, we have to move to ANCOVA. So we'll go to how, go to analyze, general linear model, univariate, and then we leave everything as it is. Just click model, move to full fractional, and press continue. As you can see it here. And here we have to go to the option and select descriptive statistic, estimated of effect size, observed power, homogeneity test. And this is in order to estimate the effect size. And if you are interested in post hoc, select observed power, which is here, observed power. This is post hoc. And you click compare mean, effect, continue, and press OK. We are interested here in the test of between subject effect. So how to interpret these results? First, we are looking to the descriptive table. As you can see it here, low level, middle level, and high level with the mean. From the table above, we have the score of the three level of socioeconomic level. The higher mean score in for high level, which is 56.50. Comparing with other level, but we do not know whether this is statistically significant or not. The second table, we are going to test Levene's test of equality of error variance. And here we are looking for the significant value or p-value greater than 5% in order to meet the assumption of homogeneity of variance. In our example here, seek our p-value 47.1%, which is greater than 5%. This means that the result does not violate the assumption of equality of error variance or the homogeneity of variance. Here we can continue to interpret the outcome, but if p-value less than 5%, meaning that this evaluated the assumption of homogeneity of variance, then we cannot proceed to the analysis. Or if we continue for analysis, then we have to mention the assumption of homogeneity is not met, and the result affect the accuracy of any decision you will take. And then we have to move to the third table, which is the test between subject effect. We look at the variable here to the levels of socioeconomic, and we look to the significant value. Here we are looking at the independent variable, which is the categories level of socioeconomic corresponding to p-value, which is 0.009, which is less than 5%, meaning that the three levels are significantly different than one and another. Then we look at the effect size, which is 0.047, which represents 4.7%, and this represents the percentage of the dependent variable read explained by independent variable. We look at the variable and the covariate variable right corresponding to p-value less than 5%, which is statistically significant. This means that the covariate variable right has significant effect on the dependent variable read. Then we look at the effect of the eta, as you can see, 32.7%, which is nearly 33%. So the covariate right explain about 33% of the dependent variable read. Then we have to move to a fourth table, which is the mean, the estimated marginal mean. As you can see it here, pairwise comparison, as you can see it here, the level, low level, middle level, high level, and the mean. Here, as you can see it here, we can see the three mean, which is the adjusted mean of the dependent variable, significantly different from each other. Then, as far as we have significant level, as you can see it for the level, statistically significant, then we can run post hoc test. How? I'll go to analyze, compare, general linear model, univariate, and then we leave everything as it is for pairwise comparison. So we have here low level, middle level, we look to the p-value or significant value. Low level with high level are not significant because p-value greater than 5%, which is 18.4%. But low level with high level less than p-value less than 5%, which means statistically significant between low level and high level. And then middle level with high level also statistically significant, which is 0.9%. And this is because the levels in the estimation is statistically significant. And then when the p-value less than 5%, meaning that these two levels are statistically significant, different from each other. Low level, high level, middle level, high level. Please put your comment in the comment area, and I'm happy to help you, and thank you. Next video I'm going to talk about two-way ANCOVA. Thank you.